Hello guys, after the configuration of IPv6 address on Cisco Packet Tracer, we have to compare some IPv6 address types here. So today we are going to discuss about IPv6 address types. In address types, we have so many things in this. Like IPv6 has so many address, like it has unicast, link local, unique local, and so many addresses are there. So we have to discuss it one by one because IPv4 consists unicast, multicast, anycast address. In this, an interface is expected to have multiple addresses. Okay, so it also listen to various multicast address, sometime unicast, sometime multicast, sometime broadcast. So in IPv6, yes, broadcast address no longer exists, sorry, but rather another addresses are already exist. So first of all, we have an address named unicast. Here you can see unicast is there. So unicast is one-to-one communication. We know that one-to-one communication. In this unicast address, it uniquely identify an interface and transmission to a single receipt. Okay. In unicast, after unicast, we have link local address. In link local address, scope is limited to directly attached network. The link local address is represented with FE80:/10. It is link local address. And after link local, we have unique local address. Technically, the scope is global. Unique local address, technically its scope is global, but it is really limited to your network. We can say it is similar to private IPv4 addresses. IPv4 private IP address is similar to this, but unique local address, the type of unique local is FC00:7. And after this, we have global unicast. Its scope is global. It is similar to IPv4's public IP address, but in IPv6 it is of like this. Okay, after that, after unicast, link local and multicast, we have address a global unicast, multicast. Multicast, you know that transmission to several receipts, one to many transmission. In this we have two types also. The two types are, one are assigned. First of all, I have to remove this. Multicasts are divided into assigned, and also multicasts are divided into solicited node. Okay, so assigned address are FF0S:8, and these address FF02:1, FF00:000, but it is not used as a practical, so it is just address of multicast. So the important thing after the multicast is anycast address. Anycast is a collection of devices share the same IPv6 address. Transmission is to the closest address, like topographically, and it is identical to unicast, so only difference is administrative. Okay, so anycast address is a collection of device which use same IPv6 addresses. And after that, we have modified EUI. First of all, we need to understand what is EUI. So this is the theory topic, EUI. EUI is extended unique identifier. Now, what is this actually? So EUI64 is, for example, a host can automatically assign itself a unique 64-bit IPv6 interface identifier. Okay, we don't need manual configuration or DHCP. In EUI, it will automatically assign. So EUI64 is also like modified also. There is a type is modified also. In this, the 7th bit is the universal bit. So yeah, 1 for universal, and 0 is for local. And at last we have one more type, and the type name is Oh, okay, so I will write it only. It is auto configuration. Auto configuration is similar to DHCP in IPv4. Okay, so router running in IPv6 can give the network prefix and gateway address to client looking for an IPv6 address. Okay, so these are the IPv6 address types. Thank you so much. Hello friends. So in today's video, we will discuss about IP parameters. So I need to verify the IP parameters in different client operating systems. Okay, so current this time I'm using my window 10 here. Okay, so this is the screenshot that I have taken from my window 10. So within IPv4, we can give IP address, subnet mask, default gateway, also DNS server. So if you want to see the practical, then I will show you. Then in control panel, we have to click in control panel, network and internet. After that, after network and internet, network and sharing center, change adapter setting, and here you can give IP address, IPv4. So here we have different things like obtain IP address automatically and use the following IP address. So here you can give IP address, subnet mask, default gateway and DNS server. Okay, in advance, if you want to give multiple IP address to your operating system, then you can add here TCP IP address, DNS address and your WINS address here. Okay, so I'm not going to give address this time because my system is connected to internet, because IP is based on internet. So if I will change the IP address, then definitely my internet goes shut down. So that's why I have taken screenshot. Sorry. So this is the screenshot taken from window 10. In this you can see IP address, subnet mask, gateway like 192.168.1.25, gateway is 1.1 and subnet mask is 255.0.255.255.255.0. So that it is window 10 operating system. So there is no difference of IP addressing in Mac operating system, but the difference is virtually like Mac operating system is different. But in Mac operating system you can give Ethernet IP address, and here you can see the status, cable is unplugged. After that you have to give it manually IP address, subnet mask, and router keyword knows same as default gateway. Like in Windows operating system we know it as default gateway and in IP Mac configuration it is known as router. So here we have DNS server. So besides this, I have taken screenshot for Linux operating system also. Here same we can use IP address, broadcast address, subnet mask, default route and primary DNS. So the IP configuration is easy on each and every operating system. Thank you so much. Hello friends, our today's topic is about wireless principles. As we know that Wi-Fi device or Wi-Fi router is used to connect with the radio frequency or the radiations with our laptops. So if we are not able to connect our device with switch or router, then we can directly connect with wireless. Okay, like my mobile is not able to connect with switch. Okay, my tab is not able to connect with switch or router, so I can connect it with wireless router. So today we have to discuss about wireless principles, like within wireless what are the things used and how Wi-Fi router is work. Okay, so first of all I have a point, non-overlapping Wi-Fi channel. Okay, so in non-overlapping Wi-Fi channel, what is this? Okay, first of all we need to know about that. It might be obvious that the wireless device, okay, for example this is wireless device or any access point which has antennas, all the wireless device and access point should all be capable of operating on the same band. Okay, let me explain you in different manner. For example, a 5 gigahertz wireless phone can communicate only with the access point that offer Wi-Fi service on 5 gigahertz channel. Okay, so this is my mobile phone. It has a 5 gigahertz frequency. So it is communicate with the Wi-Fi service if this access point provides the 5 gigahertz channel. Okay, in addition, the device and access point must also share a compatibility with the part of 802.11. This is the standard by IEEE 802.1 standard, this port. Okay, as we know that IEEE 802.11 Wi-Fi standards evolves and develops new amendments in the functionality of the get purposed. So we have to think about these things, and it is common to see the amendments which still used to distinguish specific functions. So non-overlapping Wi-Fi channel is example of this. After that we have SSID. What is SSID? SSID is service set identifier. Okay, so it is known as your broadcast ID actually. Okay, when for example you are going to connect your laptop with your Wi-Fi router, then you can check there are so many wireless names are there. Okay, so SSID is your service set identifier. Service set identifier. Okay, it is also under the 802.11 wireless networking standard. It is known as service set. It is your broadcast ID of your Wi-Fi name. Okay, for example, I have XYZ private limited company. Okay, so I want to connect with my Wi-Fi network. So the name of the company should be XYZ private limited, and easily we can connect with the help of service set identifier. And when it is connected with the service set identifier after giving its wireless password, then automatically my PC's MAC address is assigned with my Wi-Fi router. Within we have so many modes, we have so many frequencies are there. Okay, so MAC address is assigned with my Wi-Fi channels. Okay, the third part is my radio frequency RF. Okay, now in wired link the electrical signal is used. For example, if you are working with switch or router, what is known as RF? RF is your one second radio frequency. Radio frequency is used in wireless because if you want to send data with one system to another system with wire, then you know that we have electrical signal is used. Electrical signal is used at one end and at another end. So wire itself is a continuous and conductive, so that signal can propagate rather easily. But in wireless we don't have any physical standards, so we have to carry our signal with some radiations. So that signals that carry our electrical signals over air or free space, okay, the radiations, this is done with radio frequency. So radio frequency is used to connect our wireless devices with each other, like sender and receiver easily can get the information and send the data from one interface to another interface. Okay, so the last point in wireless is encryption, because wireless networks are complex. Okay, so encryption is important in this time, because if we don't have any wireless network security, so anybody can access our data easily within our given range. Okay, so why we need encryption in this? So first of all I will remove this. Okay, so encryption is used for like identify the endpoints of wireless connection. Okay, you want to verify the end users, you have to protect with eavesdropping. Okay, you want to prevent your eavesdrop, and after that you want to protect from data tampering, you also need encryption technique. So in encryption you can use authentication. Okay, so we have authentication also, WEP privacy as well as WPA privacy this time. Open authentication is like your Wi-Fi router with free Wi-Fi. They have no Wi-Fi password, so you can connect easily. WEP is wired equivalent privacy. This one is in encryption. WEP is a wired equivalent privacy, but it is a non-secure nowadays. So nowadays we are using WPA, wireless protected access. It is secure because in this encryption part is more. We can use our special case sensitive words like @ hash and percentage sign in this. So these were the wireless principles. Thank you. Hello guys. In this video, we are going to discuss about virtualization fundamentals, like what are virtual machines. Okay, so virtualization is the process in which we can use multiple operating systems at one time, and the virtual machine is same as like a software in which you can run multiple operating system at one time. So for virtual machine installation, you can use so many software. We have so many software that are used nowadays. So we have VMware in which we can install multiple operating system. We can use VirtualBox. Some virtual boxes are from Open and some belongs to Oracle VirtualBox. So we have so many virtual machines are there. So in this video I am going to configure one virtual machine, and first of all I need to install VirtualBox or VMware. So I already have set up. In this setup, I'm going to click on VMware workstation. This is my old version, like it is already cracked. So I have to click on this. This is VM workstations 8. So it is going to install. Like first of all, you need to go for next. And like you want to use typical or custom here, like typical program feature will be installed, so I am clicking on typical. So if you want to check the update, then you can click on this, otherwise you can untick this. And after that, if you want to improve your workstations, then you can click on this. So next, if you want to create shortcuts on desktop and start menu, then you can use this. Okay, let's continue this. Okay, so now it is going to install. In this VMware, we can install multiple operating system as I have told you before, and we can install Windows 7, Windows 10, Linux, Kali Linux, any operating system that you need, you can install in this VMware VirtualBox or VMware stations. Okay, so the package is installing because it is used for some requested operations. Okay, so it is installing. So it is taking some time because we have so many backend files. So this may take several minutes to install. It will install some tools. It will install some data backups. There are so many packages, like they have to set up for Windows operating system, Linux operating system, Mac operating system also. So that's why it is taking some time. So we have to wait for some time, and after installing and configuring all the things in VMware, we can install any operating system in this. Okay, so setup wizard is complete. It is finished. Now I have to check. There we have one key. If you have cracked version like paid version, you can click on this, and now you have to check that your VMware is installed or not. So it is installed. So now it is going to open. Yes, already I have installed Windows 7 machine in this. Okay, so if you want to install a new virtual machine, then we have to start from scratch. Click on create a new virtual machine, typical. Now if you want to install Windows 7 64-bit, then you have to click on 64, otherwise you can click on 32. If you have another operating system, then you can also install this. So I'm just taking an example of Windows 7 Ultimate 32-bit. Next, okay, so in this portion you have to give the product key. If you don't have product key, don't worry, after that you can update it. So full name you have to give. XYZ, anything you want to give. If you want to give the password, then you can give password there. Next, click on this. Now this, it will take some time. It will make the directory. You can change the preference also. You can change the bits also. If you want to customize hardware, then in this memory, processors, network adapter, USB controller, then you can add or remove the functions. Like for example, you want to run the internet on this, so by default it is clicked on NAT, used to share the host IP address. But if you click on bridge, then you can use the internet direct from your main PC. Okay, so for this time I'm remaining it same. Finish. So my VMware is installed, and now my operating system is also going to install. So after installing this operating system, your Windows 7 will be there. So it will take some time. So that's why I already have installed the window. Okay, so you have to click on File, Open, and where your VMware is installed, virtual machine. So you can click on this and click on this. So you can open this and you can click on this, you can resume this, you can set the meeting settings or anything else. So this is all about the Windows 7. So already my setup is starting because it will take at least 20 to 30 minutes to complete. So after completing this, it will be installed like my original Windows 10, Windows 7 is using. So this is the part of virtual machine. Okay, so I already have installed. So this is all about virtual machine. Instead of VMware, you can also use VirtualBox or any other softwares. Thank you so much. Hello guys, again I'm in front of you. Today we are going to discuss about our next module, which is known as switching. So it is my 1.13 module, in which I have to discuss about various switching things. Okay, like we have a switch, so we need to discuss about how switch works and how it transfer frames from one interface to another frame. Okay, so in this switching concepts, we have to discuss about what is MAC address and how MAC address and its aging. Okay, and after that we have to discuss about what is a frame switch, like how to flood the data, what is broadcast access. So many things are there. So first of all, we need to know about the basic concept of what is switch. So switch is a layer 2 device. Layer 2 device means it is a device which is used to connect with PCs with each other. Okay, so this PC wants to send data to this, and it can easily send data transfer with the help of IP address. Okay, so we know that in our last video we have discussed about IPv4. In IPv4 we have seen that PCs are configured with IP address, but switch is not able to learn IP address here. Okay, so switch makes one table which name as MAC address table. Okay, now how one PC transfer data to another PC? So when one PC, for example 10.0.0.1 wants to ping with 10.0.0.2, so first time switch will broadcast. So in which switch will broadcast? So data transferred to everywhere. So it means this is known as like frame flooding. So it sends their frames to everyone, but frame is received by only 10.0.0.2. So after broadcast, it will go for unicast process. Okay, when every PC pings with like 3, 4, 5 ping with each other, then there is one table is made which known as MAC table. Here is port number 1 by 0 by 1, 0 by 2, 0 by 3. Then for example MAC address of first PC is A, second PC is B, third PC is C. So this is the process of MAC address. Now what is MAC address? MAC address is 48-bit hexadecimal address, which is known as your physical permanent address. So in switch, it learns the MAC address of every device, and put that MAC address into the MAC table. So first time it will go with broadcast, but when first time broadcast is done, then in MAC table we got the entry, as I know that three entries are here, A, B and C, and obviously 1, 2, 3 systems are connected with switch. So if switch know the MAC address, then after that it will not go with broadcast technique, it will go with the unicast technique. So this is the process of actual switch from backend. Okay, so now I'm going to let you know about the practical of this. Okay, so I'm going to open my Cisco packet tracer. So I just want to show you about like how it will work. Wait. Okay. Okay, so Cisco packet tracer is open. So in Cisco packet tracer, I'm taking one switch here and I'm taking PCs from here, 1, 2, 3. Okay. So the PCs are connected with switch. For example, I have given 10.0.0.1 to first device, 10.0.0.2 to second device, 10.0.0.3 to third device. Okay, so first time, well, when it is transferring the data, you can check here. So I'm using like first time it sent the data from one to another, it will broadcast. It is sent by only this PC. So when again it wants to forward the packet from one interface to another, then it will not go with broadcast. But if PC sends data to another PC, for example, this one, this sent to this, successful. Now actually I have done pinging with this, so that it will not go for the broadcast, so it has given unicast. Why it is going with broadcast to multicast? So I have to check the things. So in this, first of all, I will up the fonts. Font size are again less. So an option, preference, font. I will use this. Okay, no issues. So you can check from here. This is go for show MAC address table. Show hyphen MAC address table. You can check MAC address is already assigned with this. So if MAC addresses are there, then switches go for one-to-one process. If MAC addresses are not there here, for example, MAC addresses are clear. For example, I will clear the MAC address manually, so it will again do broadcast. So this is the concept of switching technique. Thank you so much. Hello everyone. Our today's topic is about switching. So in our last video, we have learned about switching concept, what is MAC address, what is frame switching, how to connect with one switch with another switch. So today we have to do practical topic, which name is VLAN. First we will do the theory of VLAN, and in our next video we will do the practical. Okay, so the topic, as the name suggests, VLAN known as virtual LAN. Okay, so what is virtual LAN? So virtual LAN is used to break the broadcast domain of a switch. Broadcast domain on a switch. So in our theoretical part of switch, we know that the switch has one broadcast domain and many collision domain. Okay, so VLAN is virtual LAN which is used to break the broadcast domain. For an example, I will show you with an example. For example, you have connected 4 PC with your switch. Okay, so we know that by default every port is doing broadcasting. Why it will do broadcast? Because all the ports of switch like F0 by 1, 0 by 2, 0 by 3, These all port of switch by default the member of VLAN number 1. It is known as default VLAN. So VLAN 1 is known as default VLAN, and by default all the ports of switch are the member of this. So if our IP address is like 192.168.1.1, 1.2, 1.3 and 1.4. So if I will ping to my broadcast ID 255, I'm using /24. So if I ping from this PC to broadcast, then 234 means every PC will reply to my first PC. Okay, but in VLAN what we can do, for example, if you want to divide these two PC in one domain and these two PC in one domain, so what we can do, we can make VLAN number 2 or VLAN number 3 here, and after that I will assign the specific port to specific VLAN. So it is used to break the broadcast domain. So in VLAN what we need to learn about it. So first of all, VLAN is a numbered range. So by default I told you that VLAN 1 is default VLAN. Okay, so 1 to 1005, it is a range of numbers in which 1, 1002, 1003, 1004 and 1005. These are already made VLAN on every switch. Okay, I will check on Cisco Packet Tracer and let you know about it in our next video. So by default all the ports are in VLAN 1 by default. Okay, so these are the already made VLAN. So if we want to make VLAN, so we can use this number range. Like we can make VLAN number 2, VLAN number 3, VLAN number 400, VLAN number 1000. So we can choose any number which I need. Okay, so maximum VLANs ported locally is 255. Okay, but we can extend the range. And after that what we need to learn, if our switch is connected with our PC, then that port is named as access port. Okay, access port. So if switch is connected to switch or switch is connected to router, for example, then that port is not renamed as access port, it is the trunk port. Trunk. So why we use trunk? Trunk is used to transfer VLAN database from one interface to another interface. So this is all about the theoretical of VLAN, like VLAN number range, access port and trunk port. In our next video we will discuss about how to configure VLAN on switch. Yes, one more thing I just want to discuss here. VLAN is divided into two parts, like we can transfer data as well as we can transfer voice. It's up to you that with the help of VLAN you are making data VLAN or you are making voice VLAN. So in our next video we will talk about the practical of VLAN. Thank you so much. Hello everyone. Our today's topic is practical of virtual LAN. So in our last video we have discussed about access port, trunk port, VLAN range. So in this video we will practically implement how to create the VLAN. So first of all I need to have one switch. Okay, and I need to take PCs here. For example, 4 PCs are there. Okay, I will take one more switch here, because we have to implement VLANs on multiple switches. So I will use 2 ports here. Okay, so I'm going to connect PCs with switch. Okay, and switch to switch is connected with cross cable because these are known as same devices. So okay, so this is a LAN. So LAN means devices are connected with same network ID. So I'm just taking 192.168.1.1, 192.168.1.2. I will copy this. so that's why it is easy to implement the configuration. 3, 4, 5, because first we need to check the broadcast domain, so I will ping to broadcast ID. So if everyone will be ping, first of all you can check with this part also. Okay, you will check here successful. Okay, so I am going to ping the broadcast ID first, like ping 192.168.1.168.1.255. So you can check 2, 5, 6, 3, 4. Everybody is replying to my PC 1.1. It means if I am sending hello in one classroom, then every student will reply to me. This is called broadcast process. Okay, so what we can do with the help of VLAN? So first of all, on our first switch, I will put the command show VLAN, option, preference, font. So I will change the font number according to my switch, but it is not going to change. It's okay. It is visible. Show VLAN. Okay. So in show VLAN, what you can see by default here is VLAN 1, 1002, 1003, 1004, and 1005. And by default, all the ports of switch F0 by 1, F0 by 2, everybody are the member of VLAN 1 by default. So I want to change the broadcast domain. So what I will do, I want to make these PC in VLAN 2 and these PC in VLAN 3. Again same as VLAN 2, VLAN 3, so I will write it. Okay. I will write it here. This is VLAN number 2. This is VLAN number 3, VLAN number 2, VLAN number 3. So I have to create VLAN here first, and after that assign port specifically. So one thing you need to be in your mind, the ports that are connected to switch PCs, they are known as access port, and the port connected directly from switch to switch, it should be configured with trunk, so that we can transfer our VLAN database from one switch to another switch. Okay, so I'm going to configure on switch. Okay, first of all I will erase this. Config. I will put the command VLAN 2, and I can put any name to this name. For example, HR department, exit, VLAN number 3, name, marketing department, exit. Okay, so if I will check now show VLAN, okay, then you will check there VLAN number 2 and VLAN number 3 is there. Okay, so VLAN number 2 and VLAN number 3 is there. So I have to put the ports in this. So I'm making data VLANs first. So I can put the range command here, interface range FA0 by 1 to 2, switch port mode access, switch port access VLAN 2. This is the command. I will put all the commands on notepad because the screen is short. Interface range FA0 by 3 to 4, switch port mode access, switch port access VLAN 3, do show history. So I'm going to copy these commands and I will show you on this board. So this was the VLAN number 3, and VLAN number 2, name HR, exit. This was the command that I have used on my first switch. So same as I have to put command, this is VLAN 2 and this is VLAN number 3. So now we don't need any range. Interface FA 0 by 1 switch port mode access, switch port access VLAN 2. Okay, so if I'm not able to make the VLAN, then you can see access VLAN does not exist. It is automatically creating VLAN 2. So if I have not created VLAN yet, then automatically it will create VLAN if I will use this command. Switch port mode access. Now it will create VLAN number 3. Okay, so check in VLAN, show VLAN. 1 and 2 are the part of 2 and 3 VLAN respectively. And if I will check on switch number 1, then you can check 1 and 2 are the member of HR, 3 and 4 are the member of marketing. So the meaning of VLAN is now 1 and 2 will connect with each other. Okay. After that, I will hide it. This one will be ping with each other, but they are not able to ping, and they are also not able to ping because the broadcast domain of the VLAN of the LAN is break. Now you want to ping VLAN number 2 on first switch to VLAN number 2 on second switch. So if you want to create a link between two switches, then you have to put trunk command in between the switch. So on first switch, the port F0 by 5 is connected with second switch. So I have put command switch port mode trunk. So switch port mode trunk command should be at least on one interface. There is no need to put trunk command on both the interface. You can put that command only to one interface. If trunk is enabled, then VLAN 2 is able to ping with VLAN 2 on another switch. And if now you are going to ping with broadcast ID, then only 2 and 5 will reply to you, because 2 and 5, they are the member of VLAN 2. And if you are going to start VLAN with VLAN number 3, then you can check ping 192.168.1.255. 4 and 6 will reply. So this is the method of VLAN, like you can break the VLANs. So the command used for switch port mode access, switch port access VLAN 2 is used for data VLAN. For example, I'm just taking an example. You want to apply voice VLAN here. So I'm just going to change this port into voice VLAN. Okay. Like interface FA0 by 4. The command is same, switch port mode access, switch port voice VLAN, for example 3. Now I have applied F04 with voice VLAN also. Like if you want to transfer voice from this link, then you can transfer. So this is all about the concept of VLAN. Thank you so much. Hello everyone. Our today's topic is about inter-switch connectivity. And first of all, we need to learn some theoretical concept before doing the practicals on Cisco Packet Tracer. So in inter-switch connectivity, we have to work on another encapsulations. Okay, so in inter-switch connectivity, first we need to learn about trunk ports again, like what are trunk ports. Second thing, what is 802.11 Q encapsulation, and what is a native VLAN. Okay, so in our last topic we have learned about VLAN, that VLAN is used to break the broadcast domain. If we have same network IDs, PCs are connected with each other with the help of switch, then we can break the broadcast domain and we can make logical grouping of the PC that are connected to switch. Okay, and trunk ports are used to transfer VLAN database from one switch to another switch. Like for example, I have connected 3 switch, and on first switch I have used VLAN 2 and 3. and on another switch I have again VLAN 2 and 3 and again VLAN 2 and 3. 2 3 2 3 2 3. So if you want to ping with 2, then you have to put trunk port here, like transfer the VLAN database. And one more thing, if for example here is VLAN number 4 and here is VLAN number 4, but there is no VLAN number 4 on second switch, then we have to put the VLAN tag here. VLAN tag here means like we have to make manually VLAN 4 here, so that VLAN 4 can communicate with VLAN number 4. Even we don't have any PC assigned to VLAN number 4, so with the help of trunk we can transfer our database from this port to another port. And in second part we have encapsulation named 802.11q. Okay, so this is the encapsulation given by IEEE, and this encapsulation is used when switch is going to connect with different broadcast domain. For example, 10.0.0.1, 10.0.0.2 here, 20.0.0.1 and 20.0.0.2 here. Okay, so if you want to ping these 10 and 20 on the same switch, and already they are on VLAN 2 and VLAN number 3, so I will use multi-layer switch or router, and we can transfer our database from this port to this port with the help of 802.1q encapsulation. And at last we have one VLAN, that name is native VLAN. Okay, native VLAN is simply one VLAN which traverses a trunk port without a VLAN tag. Like we don't need to tagging with the VLAN, we can use specifically native VLAN here. So this is the part of inter-switch connectivity in which we need to know about native VLAN, 802.11q, like dot 1q. Actually the encapsulation name is 802.11 means standard, but 802.1q means dot 1q encapsulation, and after that there is a trunk port. Okay, thank you so much. Hello friends, our today's topic is about inter-switch connectivity practical. Okay, in our last video we have discussed about trunk ports 802.1q and after that native VLAN. So in our today's practical we have to go with the different broadcast domain, and after that we have to connect that broadcast domain. So to connect with the two broadcast domain, we can use multi-layer switch as well as we can use a router also. So in switching we are using already switch and multi-layer switch. So in this practical I am preferring router here. So I am going to connect the switch with router also. So first of all, in inter-switch connectivity, what I have to do, I have to put these two switch in these two PCs in VLAN number 2 and these two PCs in VLAN number 3, and besides this I have to put these VLAN number 2 network is 100.0.0.1/29, sorry 100.0.0.0/29, and it is my 200.0.0.0/29, like with different broadcast domain by default. Okay, so I will write it in Cisco Packet Tracer. I have sticky notes here. So this is the network of 100.0.0.0/29, VLAN number 2, 200.0.0.0, VLAN number 3. So first of all I have to create VLAN first. So VLAN number 2 and VLAN number 3. So what I have to do, enable config. Okay, so in this I have to put the command VLAN 2 and I have to give name. Name is optional. If you don't want to give name, then it is also okay. So I am not putting any name here. I am putting VLAN 2 and VLAN 3 simply. So if you will check this do show VLAN, then you can check VLAN 2 and VLAN 3 with their default name is already made on the switch. Okay, so in our last practical we have done this, that we can use interface range FA0 by 1 to 2, switch port mode access, switch port access VLAN 2, and interface range F0 by 3 to 4, switch port mode access, switch port access VLAN 3. And don't forget to make that trunk link, because F05 is directly connected with router, so we have to make this as a trunk port. So interface FA0 by 5, switch port mode trunk. Do show history, you can check history here. Okay, so our switch part is done, and you can check. I forgot to give the name, sorry, 100, 001, 255, 255, 255, 248, because IP address I have to give. Okay, 100,006 is my gateway. 100,002, 100,006 is my gateway. 248. So on the next PCs, 200. So 200,006, 200,002. I forgot to give the IP address at very first place, but you have to give IP address at very first time. Why? Because after designing you have to follow the module IP addressing. 200, sorry, 200,006. Okay, so now they are pinging with each other, 100 and 100 ping with each other, 200 and 200 ping with each other, but we have to make inter-switch connectivity, so we have to ping 100 and 200 with each other. So for this I have to use encapsulation 802.1 queue. Okay, so I'm going to click on router. So I have to use here concept of sub interface, because I'm not able to give two IP address to one interface. So if I am able to give secondary IP address to this interface, then I am not able to ping two VLANs with each other. So that's why I have to use here FA0 by 0 with no shut command, and after that I have to use here interface FA0 by 0.1. You can choose any number range up to 4.29 billion. So I'm choosing 1. Okay, so if you are going to give sub interface here, then the main requirement of this interface is encapsulation. Why? Because you are not able to give IP address to sub interface. Okay, if you want to try, I will try to give IP address 100,006, 255, 255, 255, 248. Then they will provide you an error like configuring IP routing on a LAN sub interface is only allowed if that sub interface is already configured as a part of IEEE 802.10, 802.1q and inter-switch link VLAN. So we have to use encapsulation.1q here and VLAN number 2. So then if we are going to give IP address, it will be taken by the port. So F0 by 0.2 encapsulation.1q3 and the IP address should be 200. Do show history. So you can check you have configured sub interface IP with encapsulation.1q command. So now what switch will do? 100 with the help of sub interface can ping with the router. 200 also can ping with the router, and after that you can specifically ping 100 to 200. First packet is failed and after that second packet is successful. But if you want to see the route from 100.0.0.1 to 200.0.0.1. You can capture the packet. You can check the ping is done by router, not with the switch. So this is known as inter-switch connectivity with 802.1q encapsulation. Thank you. Hello guys, our today's topic is about layer 2 discovery protocols. So in layer 2 discovery protocol, we have to discuss about CDP and LLDP. Okay, so first of all, we need to know about these two protocols. Basically, these are known for the neighborship protocol. Okay, so first of all, I'm going to discuss about CDP, and the full form of CDP is Cisco Discovery Protocol. Okay, so Cisco Discovery Protocol is a Cisco proprietary protocol that is used for like collecting directly connected neighbor device information like hardware, software, device name, initials, and many more. And in CDP we have two versions like CDP version 1 and CDP version 2. So we have two types of version in this. So what is the difference actually? The initial version, which is capable only to collect device information connected to next end. Okay, so this version is used for collecting the information directly connected device to the direct end. While if we talk about CDP version 2, in CDP version 2, it is the most recent release of the Cisco protocols. It provides more intelligence device tracking. Okay, like for example, you want to track your interface. You want to check that your VLANs are mismatched or your trunk links are up or not, mismatch in duplex state. So CDP version 2 is better than CDP version 1. While if we talk about the another protocol here, which name is LLDP. So LLDP is also a protocol which is similar to CDP, but in LLDP it is known for layer 2 discovery protocol. So it means it works on the switches. Okay, the big difference between the two LLDP and CDP is that LLDP is a standard while CDP is a Cisco proprietary protocol. Like you can say that Cisco device support the IEEE 802.1 AB versions of LLDP, and this allow non-Cisco device to advertise information about themselves to our network device. So it is the difference between LLDP. Now I have to move on to the practical part, that in practical I have to check on Cisco Packet Tracer how it will work. So I have to erase all the commands here. Okay, so in this hope this is seen by you. So I will just use the Cisco Packet Tracer here. Okay, so I have for example two 1841 router, and these 1841 routers are connected with each other. So first of all I am going to provide IP address here like no enable config. Okay, interface FA0 by 0, IP address I am giving it to 10.0.0.1. I am using classful network just to check about the CDP, and on another router I am going to use it no enable config, no enable config interface FA0 by 0, IP address 10.0.0.2.0.0.0. So how CDP will work here? So you want to check, then you can use the command here. So you can check with the command show CDP and after that question mark. For example, you want to check the entry information for specific neighbor entry, then you can use entry. If you want to check the interface information or status or configuration, you can use show CDP interface. Otherwise, you can go for show CDP neighbors. So if I will check show CDP neighbors, then you can check the capability codes. If we have connected routers with each other, then it will show that router is connected, the platform is this, and the local and the port ID interface is fast Ethernet 0x0. Okay, so hello time for CDP is 60 seconds and hold time is for 180 seconds. So it is showing 152 this time. Okay, show CDP interface. If you will check show CDP interface here, in show CDP interface you can check the time. 60 seconds is the like sending time, hold time is 180 seconds, and also you can check here like interface information, protocol is up or protocol is down. And show CDP entry show CDP entry star is letting you know about the duplex is full and what is the version you are using Cisco images. After that, what is your IP address and everything that you need to know. Okay, so this is CDP and link layer discovery protocol information. Thank you so much. Hello guys, today we are going to discuss about layer 2 and layer 3 ether channel. So our topic is ether channel. Okay, first of all we need to know about like what is ether channel and what we have to discuss about LACP here. Okay, ether channel is supposed to be the logical bundle of physical redundant link between switches. Redundant means duplicate links. Like for examples, this is a switch, this is a switch, and switches are connected like this. Redundant links between the switches are connected like 4 cables. It may be layer 2, it may be layer 3, so you can choose like this also. So if you are seeing that there are the physical link connected between two switch and you want to make it as a logical bundle, okay, like 4 links are converted into one single link. So this is known as ether channel. Like to create a logical bundle of physical redundant links between switches is known as ether channel, or you also called it as like aggregations of the links. Okay, so after aggregation we have to go for the practical part, but before the practical part we need to understand the concept used by ether channel. And Cisco has one version of ether channel which named as PAGP, port aggregation protocol, which is used by Cisco, but now we are working on LACP, link aggregation control protocol. In link aggregation control protocol we have 2 modes, active mode and passive mode. So it is working like same as in the previous version of Cisco, that in PAGP we were working on desirable and auto mode. So the work is done in PAGP as desirable, same work is done by active mode, and the auto mode for PAGP same represent the passive mode in LACP. So let's have some practical. So I have to open my Cisco Packet Tracer first. On Cisco Packet Tracer we will configure our ether channel. So this is our Cisco Packet Tracer software. So I will enlarge the size of Cisco Packet Tracer and after that we will configure it. So you can use it for both layer 2 and layer 3 switch, it's up to you. For the current time I am using 2 layer 2 switches here and I am connecting 1, 2, 3 and 4. So I have connected 4 links between 2 switches. So you can see that by default one switch ports are green and another switch ports only one port is green. This is because of spanning tree protocol, because spanning tree protocol is used to avoid the loop between 2 switches, so that only one port is open at one time. Okay, so now it is used for loop avoidance. So I want to use as a link aggregation control protocol. So what we have to do, I have to go for the CLI command and in CLI enable configure interface range FA0 by 1 to 4, because we have taken 4 links, and switch to switch the mode should be configured as a trunk, because trunk is configured between 2 switches. And now I am going to make 4 links into one bundle, and the command is channel group. So we can choose 1 to 6 channel group 1 mode. So I have told you that in LACP we have 2 modes, active mode as well as passive mode. So I am using this mode as a passive. So what is the meaning of passive? Passive means I will enable LACP only if a LACP device is detected. So make sure if you are using one mode as a passive, then another mode should be active also. Okay, so I am going to exit this. Interface port channel 1, switch port mode trunk, and I have used the default VLAN, so I have to allow that VLAN. Switch port trunk allowed VLAN 1 here. Do show history. So this was the command that I have used in my switch number 1. So you can check here. First I have used 4 interface, and after that I combined it into one mode passive, and after that interface port channel will be up. So on the other hand of switch, click on switches, enable interface range FA0 by 1 to 4, switch port mode trunk. Okay, so channel group 1 mode active. So in our first switch we have used the mode passive, and in our this switch I'm using active. Exit interface port channel 1, switch port mode trunk, and switch port trunk allowed VLAN 1. Okay, so you can check here now both the ends of switches are green, and if you will check here like show ether channel, in show ether channel you will check group is 1, that I have chosen port channel 1 here. Group state is L2 because I am choosing here layer 2 switches. Port is 4, but you can access maximum port 16, and the protocol name is LACP. So LACP is the ether channel form which is used for like the logical bundle creation of physical redundant link. Thank you so much. Hello friends, after completions of layer 2 protocols, ether channel, layer 3 protocols, we have to discuss about one important protocol which is known as RSTP, Rapid Spanning Tree Protocol, and it is the version of STP, Spanning Tree Protocol. So Spanning Tree Protocol is the basic version, and RSTP is the Rapid Spanning Tree Protocol. Rapid STP. Okay, first of all we need to understand like what is STP. So spanning tree protocol is the layer 2 protocols which is by default enabled between the switches. Okay, so what is the work of STP? It is used to avoid the loop between switches. Okay, so this protocol is used to avoid the loop between switches, like how loop is made between the switches. Okay, for example, we have to switch and we have some redundant links between switches. Okay, so STP will work like 1 port, 2 port, 3 port are sending information to another switch. For example, it is just an example. So what is the behavior of the switch? Switch receives information from one port and send from another port, receives from this and send from this, receives from this and send from this. So STP, what STP will do? It will do some election, and it will use only one port active at one time, and another 2 port will be in the blocking state, so that I can use only one port, and data can be transferred. So packet will not do like this. This is the process of loop. So to avoid the loop, we use spanning tree protocol, and rapid spanning tree protocol is the version of spanning tree. Okay, so this is the basic description for STP. So to understand STP or RSTP, you need to understand the basic terms of your spanning tree. First of all, you need to understand about root bridge, and after that non-root bridge. Okay, third part, you need to know about what is BPDU, what is your port cost, what is your bridge ID, and what is your path cost. Okay, for example, I have 4 switch here. Okay, so in 4 switch, all the switches are connected with each other. Sorry. So which is becoming the root bridge in this? So the root bridge concept is the lowest bridge ID. Lowest bridge ID. So first of all, we need to learn about bridge ID. Okay, so bridge ID is the combination of bridge priority, which is by default same on every switch, is 32768, plus base MAC address. Okay, so it is the theory topic. Okay, base MAC address. Now, for example, its MAC address is A, B, C, and D. So how STP will work here? So the lowest MAC address is of A, because priority of every switch remains the same. So the election is based on switch. Sorry. So this is your root bridge. So root bridge is the best bridge. The port of root bridge is always designated port. Okay, these all switches are known as your non-root bridge, and BPDU is known as bridge protocol data unit, like the subsequent information sent from one port to another port is BPDU. Port cost is by default defined by IEEE. Okay, so the port cost is, if you are using Ethernet, then the cost is, Ethernet port cost is 100, fast Ethernet cost is 19, Giga Ethernet cost is 4, and 10 Giga Ethernet is 2. So by default we are using switches with fast Ethernet and Giga Ethernet. Okay, so if you, okay, I will erase it first. If your switch is connected to another switch with fast Ethernet, okay, then the cost should be 19. If your switch connected to another switch with Giga Ethernet, then your cost is 4. Okay, so the less cost will be better use. Okay, the path cost is, for example, we have again these 4 switch. This is my root bridge because it has lowest bridge ID. These are non-root bridge. So every port, every non-root bridge has one port which named as a root port. Root port is their best port to reach root bridge. Like 19, 19, 19 is the cost here. So for this switch to reach root bridge, 19 cost. So this is the root port. So for this switch to reach the root bridges, this is the root port. Now for this switch, the cost is same from the both side, 38. Okay. So if it is 38, then switch will do the election based on their respective MAC addresses. For example, this is A, this is B, this is C, and this is D. So this port should be the root port because the MAC address of this switch is lower than this switch. So after that, this port should be blocked port. So it is used to avoid the loop. And the cost from one port to root bridge, the total cost to reach the root bridge is known as path cost. So this is the basic version of STP. Thank you.